All right, here is the Norman window problem. You got a rectangle with a semicircle, or maybe it's a rectangle with a semicircle, one way or the other. Um, they tell you that the perimeter is 36 feet. Now, the perimeter um, is three sides of the rectangle and then half of a circle. So the three sides of the rectangle will be 2L plus W. And I've got a half of a circle, and it's a half times pi r squared. Oh, sorry, that's the area. I want a half times 2 times pi times the radius. Well, the radius is w over 2. And so this is the perimeter, which is equal to 36. So what do we have? Let me simplify this a little. 2L plus W plus pi over 2 times W. All right, a half and the 2 cancel out. Yeah, equals 36. Okay. In this problem, we're asked to find the largest possible area. Well, the area is the sum of the area of a rectangle and the area of a semicircle. So the area of the rectangle is length times the width, and the area of the semicircle, here's where I get my, sorry, this is plus 1/2 pi times the radius squared. Well, the radius is w over 2 squared. So I've got the area equals length width plus, this is there's a half, there's going to be a fourth that comes out of this, so it's like 1/8 times pi times w squared. Okay, now there's too many variables there, so we've got to substitute for one of them, and I think probably the easiest one to solve for over here is L. Right, I've got this relationship. I need, for whatever reason, the perimeter to be 36. So solving for L, at least solving for 2L to start with here, 2L equals 36 minus W minus pi over 2W. So L is 18 minus W over 2 minus pi over 4W, just dividing everything by 2. So I can now plug that in for L here. So the area, my pen is dying here, area is 18 minus W over 2 minus pi over 4W times W plus 1/8 pi times W squared. When we get to Calc 3, we won't have to eliminate one of the variables. There's a way of doing it. In fact, my Calc 3 class this quarter is just doing that. This past week we've been solving these types of questions. In fact, we've come back to this section and taken problems out of section 4.7 to do in section 14.8. Because rather than doing the substitution and getting rid of one of these variables so that I can take a derivative, we have these other methods using partial derivatives and gradients and all kinds of things. But anyway, in Calc 1, you can only deal with one variable at a time. So with two variables in this problem, I had to know that there was a relationship between the two variables so that I can solve that relationship, plug it in, and have just one variable. Now that I've got that, I can maximize the area or minimize the area by taking a derivative. Find where the derivative is equal to 0. So dA dW here equals, oh shoot, I don't want to take the derivative yet. Hang on, before we take the derivative, I want to multiply this out because I don't want to do a product rule. So let me do 18W minus W squared over 2 minus pi over 4 times W squared plus pi over 8 times W squared. In fact, I can probably simplify that even. So I've got 18W minus W squared over 2. The thing is that this is 2 pi over 8. So I got minus 2 pi over 8 plus pi over 8. Seems like it's minus pi over 8 W squared. Just getting those two fractions together. The minus a fourth and plus an eighth is minus an eighth. Okay. Actually, I could combine those together too, but I don't know. Doesn't really matter at this point. So that's the area. So now dA dW is 18 minus w minus pi over 4w, right? And I'm going to set this equal to 0. Oops, set this equal to 0. I put it over the top because I was going to put an arrow there. I set that equal to find the critical point, right? Derivatives aren't always equal to 0, but when you're looking for maxes and mins, that's when you want. You want the derivative equal 0. So I've got 18 minus w minus pi over 4w equals 0. I'd write it this way. All right, 18 w plus pi over 4w, and then factor the w out. So 18 equals 1 plus pi over 4 w, and divide by that stuff. So w equals 18 divided by 1 plus pi over 4, whatever that is. Okay. They ask you to maximize the area given that the perimeter is 36. So you had to look at perimeters of things and you had to look at areas of things, but it's the area that you need the derivative of because it's the area that you're maximizing. Okay. There's that one.